This is NEAF Talks. And now, ladies and gentlemen, the hardest working MC in the cosmos, Vincent Coulihan.
Welcome, everybody. Welcome to NEAF 2023, the Sunday edition. We have a really great program set up for you this afternoon, and starting with our first speaker. She is a planetary scientist, a geologist, professor at Brigham Young University. Also, you may have seen her, some of you. She's a contributing expert for science discovery on how the universe works. Recently, she's been appointed to a team for Dragonfly, which is a quadcopter which will be searching the moons of Saturn. Please welcome to NEAF 2023, Jani Radebaugh.
Good morning. How's everyone today? I hope you're doing well. I'm excited to be here and excited to be able to talk to you a little bit about the Dragonfly mission to Titan. It's going to take us a little while to get there. We're going on a journey in order to arrive at this location. So I'm going to go back about 22 years ago. I found myself bumping along in a Land Cruiser down in South America. We were in the Puna, south of the Altiplano, which is another even higher and drier plateau, and learning about volcanic landscapes and eruptions, and just seeing an increasingly alien landscape as we were driving along. And we decided, okay, it's getting rougher, let's all pile into the same cars and continue from here. So leave anything behind that you don't need. And I had a first generation digital camera. It was about this big. This is just 22 years ago. Isn't that amazing to think how far we've come? And I thought, this is just so big, I'll just leave it behind. And unfortunately, I didn't have one of my Fuji, disposable cameras with me. So I left my camera behind on the seat, and we continued on. And as I continued, I started to notice a landscape even more bizarre and alien as we went forward. And as we kept driving, the landscape got rougher and rougher. Here we go. And the vegetation disappeared. And suddenly I could see lava flows crawling across the landscape. There were big gravel ridges like we're seeing on Mars. And way off in the distance were some tall little towers. You can kind of see them over on the far right. Little tiny rock towers. And we approached those, we got closer and closer, and they're big, huge pillars that are white, just bleached white, and they have tiny little crystals of quartz. And I stood right next to one and just looked at the beauty coming into my eyes and thought, why are these here? This is like Io, this is like Mars, this is like any kind of planetary landscape I've ever imagined. And where's my camera? I had no camera. Please take this picture for me and send it to me, and I never got any. The only picture I ever got back is one I really do treasure a lot, and that's this beautiful one of all of us just exhilarated coming off of this incredible landscape, and just, I'm way over on the right, and we're all just so happy to be there and see what we saw. So on that day, I vowed, I have got to get back here. I know it took me 5 days to get here, driving in a car from, Buenos Aires and then Salta, and I've got to get back here one day. And it took me I guess it's been about 17 years, but I made it, and I got back there. And now I go back and I study these incredible landscapes for NASA. Okay, well, why does NASA care about these places? And this is a video. And it's because they are just incredible. They are bleached white landscapes, these rock towers, and there's no vegetation, so that means the desert is dominating here. It is a wind-carved landscape. And so I just feel like I'm on Mars every time I'm there, walking around on these gravels and trying to examine the rock towers. Why are they here? We think they were one solid layer in the past. And next one, I think, is also a video. And we're trying to understand, okay, you can kind of see they're streaked on the sides because the wind has carved them and eroded them. And so how does the wind carve them into individual towers? Why doesn't it just scrape it all off as one solid layer? Instead, it sculpts them into these towers. And notice they're kind of hard. We can walk on them. Oh, I like to feel like I'm in Star Wars when I'm there, and dress like it as much as I can. So here I am, I'm Rey, I'm walking around and trying to see these things. And really they're so beautiful and almost ballistic in shape. They're almost the perfect aerodynamic shape that you can make. They look like submarines or like islands in a stream. And really that's the idea, is that wind is flowing around these just like water flows around islands in a stream. And from overhead, you can see that they're arranged into lanes. So here's a lane right here, here's another lane, and in between those lanes are a bunch of big gravel ripples. And again, this is just like Mars, like other planetary landscapes where the wind is in control and it's dominating and it is carving out the landscape. And they make just such beautiful forms. Look at the gravels untouched. And I mean, you just want to walk right between those and walk off into the distance. And then in some regions, the gravels are kind of dominating, and the towers are just barely poking up here and there, like islands, like glaciers poking up, or mountains poking up between glaciers. And we're out there studying them. This is another video. So here you can really tell that ballistic shape, that streamlined shape. We're walking around on them and trying to better understand how they form and what's happening to them over time. And yeah. So here we are. We can just walk around on them. We can place wind meters, anemometers on them and study which way the winds are blowing. And you would think, oh, they've got to be blowing from the left or the right to the left here. But it turns out that instead, sometimes the winds blow from the side, like here in this video with we got these smoke candles and put them out and watched what's happening. And in some cases, for this video, it is really kicking and is almost all we can take to just be out there and be experiencing it. So here's the PI of the grant, Laura, is sitting up on top of that. She's Laura Kerber at JPL, and she's just lying down, trying not to get the brunt of the wind, but they're blowing from the side, and you can even see that in the shapes here. So the more we can study these on the Earth, the better we can understand what's happening on other planets. When we look at these landscapes, because we just get a snapshot in time, we don't even know which way the wind is blowing most of the time on these other landscapes. Okay, and so we keep on going back there and keep trying to understand what's happening and what we're seeing. And oh yeah, we also bring some other tools with us. This is another video. This is really video heavy early, and then we'll settle in. But so we bring our little handheld drones, and these are really incredible devices. They take care of themselves, and they fly just about anywhere. So here's some drone footage of Laura walking off into the distance. And so we're kind of flying upwind right here in general. Although right now it's really pretty quiet, so we do have times where the wind is not blowing all that much. And you can see all of them have a really kind of even slope on their backs. They have these orange coatings that we think happens because once in a while a little bit of water creeps into there and sits on the surface, but most of the time the wind is dominating, the wind is in control. And so here we are running across the landscape and really happy. I love being here. This is my favorite place. And she's about to step in water. No, it was gravels. But it gets us every time. It just looks like a little pool of water in between these rock towers. And as we continue off into the distance, we can zoom past these features. We can see volcanoes way off in the distance. We see hydrothermal deposits. And I mean, it just is a landscape that I really think has so many planetary connections in so many ways. Okay, well, what are these like? We'll go to the next slide. There we go. Here is a picture of a bunch of these same things on Mars. And as we always find out on other planets, they're bigger. They're bigger than we have on the Earth on Mars, but they are really similar. They're wind carved, and they came out of volcanic ash, we think. We're starting to lean in that direction because the ones that we see on the Earth are mostly carved out of volcanic ash, sometimes lakebed clays, so that's exciting for Mars as well. And so why do we care about them for Mars? Well, we're going to go to Mars at some point. We'll bring humans there, and we'll try to live and work on Mars. This will happen. This will happen. And so we have these ideas, well, how do we house ourselves? There's no magnetic field to protect us. So we would like to build some houses, and these are examples of 3D printed houses on Mars. These features right here, 3D printed out of the rock. So that's pretty exciting. You can grab rock and then just print them up. Why don't we just build a house out of the wind-carved ridges and towers that we see on Mars? We already have the natural streets in between everything. We have the blocks laid out. So it seems like it would be really simple to do that and kind of exciting. Okay, well, and that helps us with our exploration of Mars. You saw yesterday from Nikki that we're exploring Mars. We're going there with spacecraft, with these incredible rovers. And here's the landing of Perseverance. Look at the clarity of this image. This is an image from Mars, and it's spectacular what we can see from there. And then there's a little bit here from the lander looking up toward the rocket, and then the rocket looking down toward the lander. And then we also brought with us a little tiny helicopter. And this is a kind of a precursor of what we're going to talk about more later on, but you can see a flight of the little tiny helicopter, and you heard from Nikki that we're at the 50th flight of this helicopter. It was supposed to work once, and it worked 50 times, and it's really hard to fly on Mars. The atmosphere is so thin. So that's exciting for us. We've got this helicopter technology, and we can use it elsewhere. Okay, but we also see, it turns out, we see these features on Titan. On Titan. Titan is a moon of Saturn, and yet we have these features. You can see a couple of arrows pointing towards some really straight landforms. And these straight features right here, how in the world could we get those unless it's from tectonics? We think maybe these features here are straight because of tectonics, but these features are straight probably because they're carved by wind. And so we have these wind-carved ridges also on Titan. What does that tell us about the surface of Titan? Maybe this is volcanic ash. Maybe this is a soft clay. Maybe this is something that is soft enough to be carved by wind. It's also being carved by water, as you can see, or not water, liquid, as you can see in the really sort of ridged terrain here. And the liquid there is a very different kind of liquid. We'll talk about that in a minute. This is a strange image. It's a radar image. We're not used to seeing this compared to visible, but the atmosphere of Titan is very thick, and so we have to use a radar to be able to see through. So you get a black and white image of the texture of the surface, where bright is rough and dark is smooth. We'll look at a few more of those. Okay, so Titan, we've gone all the way out to Saturn. We were at Mars, 1.5 times as far away from the sun as the Earth, and now we are at Saturn and Titan, 10 times as far away from the sun as the Earth. And Saturn is so beautiful as we've seen it from Cassini. And you can see the sharpness of the shadow of Saturn onto the rings. You can see the sharpness and the division between the rings. And what I like is the contrast between that and the overall softness of the atmosphere of Saturn. I think it's really got such a beautiful soft texture, especially compared with Jupiter. What about Titan? When we flew by with Voyager, and we even noted this from telescopes, Titan is really unique. It's got an atmosphere, first of all. It's a moon, and it has an atmosphere, and that's unusual. And in fact, it's an atmosphere that's really similar to Earth's. It's about 95% nitrogen, just like Earth's. The other 5% is methane. So we have organics and nitrogen in this atmosphere. And that makes it both Earth-like and then interesting in terms of the possibility for life. And so a lot of the impetus for Cassini that was there from 2004 until 2017 was to look at Titan and look specifically for any more evidence we can find for life. Okay, back to the atmosphere. Here's a whole array of atmospheres on other planets, and you notice that Titan is sitting there at 1.5 bars. We've got a very thin atmosphere at Mars, 1/100th of Earth's, and we've got a very thick atmosphere at Venus, 90 bars, but Titan is Earth-like in its atmospheric pressure. And actually that would make it very easy to explore with humans. So just keep that in mind. You don't need a pressure suit, but you need a very warm winter coat, as my friend Chris McKay likes to say. We've also seen liquids on Titan. This picture was hanging in the West Wing of the White House for a while. This is liquids on another body in the solar system, the only other body besides Earth that we know of that has got liquids on the surface, but this is liquid methane. So all that methane in the atmosphere can be a gas in the atmosphere, and it can rain and flow across the surface as a liquid. And that's really incredible. It fills up lakes and seas, just like this one here. Doesn't this look like Earth? This looks like Earth. It's got dendritic networks of channels emptying into the oceans and lakes and seas of liquid methane. And they look dark here because this is, again, a radar image. And so dark means smooth. The radar signal is hitting something very flat and bouncing off and not returning to the spacecraft. And so it is a really smooth surface. And so it appears dark here, but we think it would probably be clear in color, unless it's filled with some impurities, which most likely it is, just like other water on the Earth. But it would behave a lot like water. It's a little bit more fluid. So we've got rainfall, we've got erosion, and other kinds of things that are exactly like Earth. So maybe because we have all these lakes and seas, we have what we could say is an ocean world at Titan. This is a really special category at NASA, ocean world, because there's an ocean on the surface just like Earth. But when we look at Earth and Titan and we talk about it in that sense, we don't really mean oceans on the surface necessarily. We mean oceans in the interior. And we mean oceans of liquid water. Okay, well, why is liquid water so important? And it's because everywhere we have liquid water on the Earth, we have life. And so this is where we look in the solar system. And we've started to find out there are a lot of these objects that do have liquid water oceans underneath an icy crust. And these are all the bodies at Jupiter, Europa, Ganymede, Callisto, and the objects at Saturn, the moons of Saturn, besides Titan, Enceladus, Mimas, and Iapetus, possibly those large ones, and maybe even some of the tiny moons of Uranus, possibly Triton. And as we look at Pluto, we are pretty sure that there is a liquid water ocean in Pluto. And what would this look like? Well, you have a crust, you can see here, 50 or 100 kilometers thick, and then you have a liquid water ocean simply because you've increased the pressure of that ice. And when you increase the pressure on ice, it melts. And then you keep going down until you get to the deep interior. So we've got rocks, we've got water, we've got organic, we've got methane in the atmosphere. So that's a really special combination. In fact, with all that methane in the atmosphere, there's a breakup of that and by sunlight, a breakup of the methane, a recombination into longer chain organic molecules. And that might also involve the nitrogen. So we've got methane, nitrogen interacting with each other and making, first of all, things like PAHs, heard of this? Polycyclic aromatic hydrocarbons. These can end up being the building blocks for RNA and other things, amino acids. And so all of those materials are being made in the atmosphere of Titan. We've seen some, we've detected some with Cassini, propane and benzene and acetylene detected by a mass spectrometer on board Cassini. So we know they're being made, and then they settle down to the surface. They snow down gently and land on the surface and maybe get incorporated into mountains right here. They fill up the lakes and seas, so there might be kind of a sludge at the bottom of all these lakes and seas, a sludge of organics. So again, that makes Titan such an interesting place to go and think about the possibility for life. Well, do we know any more about it? This is a video detailing the descent of the Huygens probe down onto the surface of Titan. We did know that we should actually look at this surface in more detail, brought along with us a European Space Agency made Huygens probe that descended down onto the surface. So this is a series of images then stitched together into a movie. And you can see it's a very bizarre landscape, isn't it? And in this case, we're looking at basically true color, but just brightened up a lot because the sun is pretty dim here. And you can see bright highlands, you can see darker lowlands. Those look kind of smooth. They look like maybe they were ancient lake beds. And some erosion happening on those lake beds. Now river channels, right? As we continue to descend down, we can see a few river channels from overhead. Now we're going to land on the surface. And look at that. You can see the lamp for a minute illuminating the surface. There are rounded cobbles in this river channel, which means that there's been fluid that's flowed here and broken up these rocks and rounded off the edges, just like you see happening in river channels on Earth. And you'll see a parachute moving by. Look at that. Isn't that amazing? The parachute shadow, And in just a minute, I think we see a dewdrop falling. So that's interesting. We are seeing actual rainfall of some kind. It's not like a deluge right now, but we know that rain is actively falling on the surface of Titan, which is exciting. And then there's also the lamp spot there that's causing distortion of the image. And really just such a spectacular terrain. Okay, oh, there's the dewdrop. And here's the sun in the sky. Okay, and let's go on to the next image. There we go. Okay, so as we could see, descending down, there are these really evolved river channels, telling us again, this is an active landscape. It's not an anciently active fluvial landscape like Mars, but this is forming today and happening today. The wind is blowing, the rain is falling on Titan today. And in fact, it's carving itself into channels. Here are a bunch of river channels right here. You can see showing as bright in radar, which means they're rough. The edges of a really big crater rim. This one is 300 kilometers in diameter. Massive old impact crater. There aren't many impact craters, which tells us that the surface of Titan is quite young. And otherwise, we would be covered in impact craters just like the moon. But instead, it's pretty young. There are just a few. This one is really notable. And recognize, too, that it's very eroded, just like an impact crater on the Earth. So again, this continues to be really Earth-like and kind of a bizarre landscape. When we look at Titan in the infrared from Cassini, some landscapes start to stand out rather than just the atmosphere. So we have big, bright terrains right here that are heavily incised by flowing rivers. And you can see a kind of orange deposit at the equator, everywhere across the equator. And it turns out that that region, we just barely had the right resolution. I wake in the night sometimes thinking, oh, if we'd had twice as bad a resolution, we would never know these exist. But they are fields of sand dunes, hundreds of thousands of sand dunes across the surface of Titan. These are very big. Each of these lines you see here is about 1 kilometer wide and hundreds of kilometers long. Gigantic dunes of sand, 150 meters high. And they're really special features. They interact with obstacles. They tell us which way the wind is blowing, which here, if you had to guess, probably say left to the right. And that's true all the way across Titan. The wind is blowing at the surface from the west to the east. And that's at odds with what's happening in the upper atmosphere, so this really helps us understand what the wind is doing close to the surface. The dunes, I always tell the atmospheric scientists, the dunes don't lie, and so we have to explain them, and we have to say what's going on with the wind there. Okay, well, dunes on Titan, is there quartz sand? Here's some quartz sand from the United Arab Emirates, and this sand has been formed over eons of the formation of a big pluton of granite that's got quartz crystals in it, and then it gets eroded, and the erosion will take away everything else but the quartz and leave the quartz behind. Now we can coat it with an iron oxide coating and get the beautiful red that we see in the sand dunes of the Earth. But the sand on Titan is not quartz. There aren't silicates on the surface. There's just water ice. But then we said there are organics. And it turns out the sand is made of organic materials. What is that like? I keep trying to find an analog. Is it grape nuts? Is it plastic, little bits of plastic sand? Something like that in between. It's got to be pretty hard materials so they can survive the formation of these large sand dunes over time. And ultimately, it came from the atmosphere, but after that, we don't know. Erosion, we don't know. Okay, everybody loves sand dunes, right? You've all been to sand dunes, either at the beach or somewhere. They're peaceful, mind-expanding environments to just rest on. And they're covered in beautiful ripples. They have beautiful shapes. This is a video. They're always changing and moving. Look at this poor road. It's not going to last much longer, or the dune will move over the road and it will expose it again on the other side eventually, maybe in a decade. Maybe less than that. Sometimes they move very quickly, a couple meters a year in this location in the Salton Sea. And it's another video. The ripples can move really quickly. You can watch it over the course of just a few minutes to hours if the wind is really kicking. This is in the United Arab Emirates. And what you're seeing in the background is the next dune. And boy, it doesn't look like a mountain. It's a mountain of sand and a big valley in between with a couple of smaller dunes. This is exactly what we think it would be like to be on the surface of Titan. You have mountains of sand spaced apart from each other. And so we go to these deserts because we don't really have this kind of dune in the Western Hemisphere. So we need to go to Egypt and to Arabia and to Southern Africa and try to understand these dunes and study them. And we're dragging right now a ground-penetrating radar. You just slide it along the surface and it will image the subsurface and show the layers beneath. So you can see right here very cleanly the base of the dune. We can see all these rocks cropping out underneath the dune, so we can kind of tell how big they are, which way the sands are moving over time, and that's really useful. And it's also great for me. I bring my students. They love being out there. They love exploring. They love the challenge of taking those tracks off and getting unstuck whenever we get stuck, and helping plan our routes. Here we are in Australia. There are some very old ones in Australia as well, using the old paper maps and the land cruisers. We've been visiting the Namib Sand Sea in Southwest Africa. Look at this beautiful Landsat image. Everything's a little bit colorized, but there you can see those lines of dunes sitting out there on the, against the coast. Big rivers are cutting through. If we look at a digital elevation model of these dunes, you can see how thick they are. They're really, the sand is just standing up there. And this is just eons of rivers transporting the sand there and it being trapped between the oceans and the mountains. And we can fly over them in airplanes and get a sense of what's going on. One thing that stands out to us is the place between the dunes is drastically different than the dunes. And that's kind of interesting to us. Here there are salt flats and clays, and in some of those places they tell us about older climates from before. This used to be wet, and now it's not. Now it's dry and dead. In fact, this is called dead vlay. And the clays and the salt flats are very different from the dune sands. We think we need to expect that on Titan. The interdune, the place between the dune will be different from the dune. And we can march up the side of this dune here and get a sense of the subsurface. We really love these data. They're very good. They tell us the sand is moving up and down the long axis of the dune. And that's valuable for us in terms of what's going on Titan, where we can't measure that. Here in the United Arab Emirates, and you can see a fence behind, this is the border fence with Oman. You can see clearly the dune versus the interdune. They're very different. And in this location, the interdune gets wet. So we're in a hyper-arid desert, and the temperatures get to 135 degrees in the summer, and it never rains. But the space between the dunes gets fed by the mountains distant and erupts up underneath the surface and feeds massive oases. And in fact, there are big date palm oases all across this region. And okay, this is great. So then we have water in between the dunes here, and this is really important. It helps the dunes grow large. It anchors them in place and helps them become giant. This is a giant mountain of sand behind the truck, and it creates problems for the roads here. You can see the road and the sand kind of dancing across the road. But one thing we've noticed too is that in some places with all of that water, even though it's hyper-arid and pretty dry, you don't see other vegetation here, but you can see an organization to the mounds in the background. Do you see these? These are algal mounds. There's bacteria, there's archaea, all kinds of things thriving in this really crazy environment. And so we think that the place between the dunes where there are liquids is really good for life. Okay, and file that away for Titan. So we do just want to think about this, and this is a video of flying a drone, but this is just in Utah, pretty close to where I live. I would go there during the pandemic. I couldn't really go out to these distant locations, but I had something really great nearby. And sure enough, you can see there's more vegetation in between the dunes where the liquids can collect there. Okay, oh, next slide, sorry, I did that. So, okay, so we've got all these ingredients, key ingredients necessary for life. We have organics up in the atmosphere, and we have rainfall, we have surface processes that help bring things into the right locations with each other. Look at this one on the bottom, cryovolcanism. We said there was liquid water in the subsurface beneath an icy crust, maybe 50 kilometers thick. Can we bring that up to the surface and have it interact with the surface? Now we have liquid water, we have organics, and that is perfect for life. Maybe you could picture something, well, and maybe it would come out of something like this, and luckily we got to call this Doom Mons, Mount Doom, on Titan, which is awesome. And it just looks like, what else is it? It's got a big pit in the middle. There are flows coming out of it. What else could it be besides a cryovolcano, a volcano of liquid water? So if you can picture something like this happening, this was an eruption, it's a video from Iceland in 2021. We got to go and view this eruption happening, and it was the experience of our life. This is not slowed down, it's just very big. Hundreds of meters high, these fountains, and they cool off at the top. They feed a massive channel at the bottom, and this would happen every 15 minutes, and we just sat there and just in awe. Okay. Oh, here it is spreading out. I was just hoping, can this come down close to the ground? This is another video where I can see it and I can stand on the surface somewhere safe and watch it, and we got lucky, and it did. It came right down by the hill. And even though this is moving pretty slowly and is covered, actually we would say this is quick in lava speak. This is moving along pretty fast. But it's covered with the crust. I'm doing this with my hand because of the temperature. It's really hard to stand that temperature. And we think the same thing would be true to some degree. If you live on Titan and a volcano of water erupted, that would be very hot for you. So you want to think about things in terms of where you are. And we would be able to see a thermal signature of some kind if there could be a cryovolcano. One last one here, video. This one was taken at night when everything is just really cranking, and I'll just kind of let you watch this video. It stands out much better at night. You see the difference in the contrast in light and color. When we can watch these volcanoes at night, it's really important. And for another day, I will come back and we'll talk about Io and how exciting this would be for Jupiter's moon Io with hundreds of active volcanoes all across the surface. And certainly fountains like this erupting now, but bigger and more beautiful. Maybe not more beautiful. Okay. Okay, we were talking about dunes though. Let's go back to the dunes. This is a nice painting by Mike Carroll showing a mountain of dune, and we've got a landscape in front of us, maybe gravel ripples. And can't we just go there? So here's another video. Yes, we can go there. Here's the punchline finally. We are going there with Dragonfly. And this is a really exciting mission idea. This is a drone quadcopter. This is what will happen. It will take off. It will just drop out of a shell. It's going direct into the atmosphere. It will drop out of a shell, fire up, and start flying across the landscape. And it will land in this dune-covered landscape, hopefully with some river channels, maybe some interdune deposits that have got some liquids. We don't want too many liquids because we want to be able to take off and land in this environment. We'll stay here, we'll open up a dish, and the dish will communicate direct to Earth. So we need to be near the low latitudes, near the equator, and the seas are up at the poles. We'll do some analyses for a couple of our Earth weeks, and then pick up and fly again to the next location. It's really exciting. We've not done space exploration like this before. So it's going to fly, it's going to land, and take off again. We've been selected for flight. We just passed our first review with NASA, so we get to start building at this point. It's very exciting. Okay, I mean, what is this thing like? It's as tall as I am, excuse me, and you can see me holding just one blade, so there are two of these blades across for each of the 4 rotors that you see, and then they're redundant, so 8 total sets, and 16 of those blades all across the body. Why are we going there? It's easy to fly in this environment. We've got an atmosphere like Earth, as we've been saying, and then also we've only got a gravity like the moon. This is a perfect place to fly. The temperatures are cold, so we shouldn't have really big convective thunderstorms. We should be ready for that in case. But these big quadcopter drones are very stable to fly. If any of you've got your own, you know that they're pretty indestructible. So where will we go? We're going to go to this location right at the equator. You see a circle there for Selk Crater. We want to be by a crater, but we also want to be by sand dunes because we know that organics are in the sand dunes. So let's say we land here and we get to go across 6, 10, however many dunes, and then continue to fly up this ejecta blanket, which might be made of water ice, and that's really exciting. Okay, we've got an MMRTG, so we've got a radioactive power source back here that charges up a battery. And as we said before, we go direct into the atmosphere and we come down on parachutes for about an hour and a half because the atmosphere is very thick, and then just start flying around on the surface. We're going to use what's called a leapfrog strategy because remember it's about an hour-and-a-half communication delay to get from Saturn to the Earth. So you can't operate this in real time. You've got to let it have some autonomy. So what we'll do is we're coming into land this first time right here. We will look at the next place that we want to land and then come back and land. The very first landing will be probably the scariest because we don't really know exactly what to expect. And so we'll land in that first location, but there will be a lot of sensors on board to help in indicating where we should go. And then after, we know where to fly to the next one, and then we continue doing that leapfrog. We fly over a new location, come back to the old one, and travel across the landscape in that manner. We think we'll have about 3 years of exploration, which is really exciting. We'll hopefully go to dozens of locations. We've got the power to do that. But even one single landing, honestly, in my opinion, one landing, one scoop up, because we'll talk about in a minute how we can detect the materials, that to me is worth the entire mission. But we've got a long one ahead of us. We've got materials laid out that we want to study, this alpha, which is the dunes, the beta, which is the interdunes, the space between, and then we've got the gammas and the deltas up on the crater. All those material types that we want to understand and study better. Okay, what about the instruments? So we have a drill on board that will pull materials up, and here's a little video. We'll pull materials up into the belly, which has got a mass spectrometer. So here's the drill working, and this is out of Honeybee Robotics, which is in Pasadena. They actually used to be here in upstate New York, and then they've moved their headquarters, at least, to Pasadena. And they'll drill, pull the materials in, and we'll dump it into the mass spectrometer. We've got a whole array of tubes that we can put these into, and then cause a desorption with the laser, and we can figure out what these molecules are made of to very high atomic numbers. So we'll be able to get a good sense of exactly what the composition is inside of, in the materials in Titan. Okay, oh, here we go. The other thing we think is really exciting is this idea of chirality or handedness. Do you see how there's a mirror image of those two molecules? So the mirror image idea is, if you look at life on the Earth, just about 70, it's more than that, I think it's more like 90% of all life has got a right-handed chirality. And this means that life prefers to use that right-handedness. What if we go there and we find, oh, it's just 50-50 chirality? That's a good indicator that maybe it's just organic processes going on. What if we find a left-handed chirality or a right-handed chirality? Left-handed would say, well, there's life there, and it's definitely different from Earth. It evolved differently from Earth. At the distance that Titan is from the Earth, it would have to anyway, because it's very hard to get something from Earth through Jupiter's gravity well all the way out to Saturn. So we still think it would be an individual origin. So we have these other tests we can do to see if there is actual life there. But mainly, we'll also be looking at the chemistry of the surface. What kinds of prebiotic chemistry have gone on? We've got a gamma ray and neutron spectrometer. We can look at the surface and the near subsurface remotely and be able to see what's going on there. We've got a meteorology package that can look into the atmosphere. We've got basic things like pitot tubes and barometers and other things that we use for flight on the Earth that we'll have with us. And then we'll also have an ability, basically a geophone from the Japanese Space Agency to listen for Titan quakes. And that's really, really cool. So we'll be able to get a profile of the subsurface and maybe get a sense of how thick that ice shell is. I'm most excited about the cameras. The cameras will look down and they'll see the dunes, they'll see the ripples on the dunes. I'm showing you all pictures of Mars that I get so jealous of every time I see. And even down to the sand, we have sands of Mars that we've been able to see. And I just want a handful of sand because of everything that sand tells you about the environment around. It tells you where it came from and what it's made of. And here's my little collection of sand in my office that you can come by and see when you come visit. Okay, so we're asking these questions. What makes a planet or moon habitable? What chemical process has led to the development of life, and has life developed elsewhere in the solar system? So I'll finish with this. I was trying to make this image of Titan this morning, but I really need my space artist friends to do this for me. I at least colored it a little bit more orange than it would be normally, but didn't get it quite dark enough. And then also we have all the astronauts there on the surface, and again, they don't have spacesuits. They're doing great. They do need oxygen masks, though. But we're walking across the surface of Titan, and there are landscapes that could look very much like this one. And I'm looking forward to the ones that might have some of those liquids, those liquid methanes, liquid methane and ethane sitting there in the interdune and maybe interacting with the organics and creating a nice soup for life there. Okay, well, so meanwhile, we're sitting here on the Earth and exploring a little bit. And next slide. And just maybe, or not next slide, this is a video. Just maybe we will see something like this as we're exploring. There will be ripples in between. Maybe picture those mountains in the distance being dunes. And we would go at about this pace across the landscape, flying in our Dragonfly helicopter and exploring the surface of Titan. And this will happen for us. It's coming. Everybody get ready, and get ready to explore a new body. And actually, next one. So, oh yeah, that one. So, I didn't put when we're getting there, unless you saw that earlier. We launch around 2027. It's probably about 2028, and arrive about 2034. And so it takes a long time to get out there, but still, it's happening, it's coming. We're really excited. Thank you.